All right, this video is an introduction to parallel lines and the angles formed when you draw a transversal and going through the two parallel lines. And so the first problem that we're going to look at is problem 2-10, and it says to draw a pair of parallel lines like those shown below. So the sub is going to give you a handout with these parallel lines already drawn on it, and so all you have to do is draw a line that crosses both of those parallel lines. And so the first one I'm going to look at is I'm going to look at this one right here. I'm going to draw this line in, and that line is called, that red line that I drew is called a transversal. And a transversal intersects two or more other lines. And what happens when that does is that it forms 8 angles. So I'm just going to randomly number these angles. So angle 1, angle 2, angle 3, angle 4, 5, 6, 7, and 8. And it doesn't matter how you number them. That's just a random selection that I did. You can number them however you want. So what I want you to do is I want you to take a protractor and I want you to measure all the angles formed between your line and both of the parallel lines. And so then just write the angle measures and the angles you form. And then I want you to try it again with a different crossing line. So go over here to this set of parallel lines and maybe draw your crossing line that looks like this. Again, that red line is called a transversal. And when you do that, you can just randomly number these angles, whatever you want to number them. I'll just randomly put them, and I never put them in the same order. And so those are my 8 angles that I'm going to measure. And I want you to write down what you notice, if you notice anything interesting. And then I want you to do the same thing down here with a pair of non-parallel lines. And so, again, when you draw on a line that crosses both of them, this line is still called a transversal. And again, it still forms 8 angles. So I just want you to measure these 8 angles again, and write down what you notice, and see if you notice anything different, if the lines are parallel or if the lines are not parallel, and see if you can compare anything and write down what you notice. All right, so what I would suggest you do is you pause this video for a second and go ahead and do that activity, and then come back and see if you noticed what I'm going to talk about. All right, so attached to your note handout, you should have some postulates that we're going to talk about, and hopefully these are some things that you noticed when you drew the parallel lines and you drew in the transversal and measured the angles. But postulate 3.1 is the same side interior angles postulate, and in this same side interior angles postulate, if a transversal intersects 2 parallel lines, then the same side interior angles should be supplementary. So you should have hopefully recognized that 4 and 5 and 3 and 6 in this picture are same side interior angles. They are between parallel lines L and M, and so they are supplementary, which means that they add to be equal to 180. Another thing you should have noticed, hopefully, is that the alternating interior angles. So alternating interior angles, they are on the inside of the parallel lines, and so that's what why they're called interior. So this is the interior, this would be the exterior, and this would be the exterior. And so 4 and 6, they switch sides of the transversal, and 3 and 5 switch sides of the transversal, so they're called alternating interior angles. And the alternating interior angles should have hopefully been congruent. And then the corresponding angles, and I think you learned these in previous grades here, but the corresponding angles, so corresponding angles, they share the same relative position. So for example, 1 and 5 are both on the top side of the parallel lines that they share, and they both are on the same side of the transversal, so they share the same relative position. So 1 and 5 are congruent, 4 and 8 are congruent, 2 and 6 are congruent, and 3 and 7 are congruent. And then finally, alternating exterior angles. Alternating exterior angles are on opposite sides of the transversal, and they're on the exterior of the parallel lines. So 1 and 7 are congruent, and 2 and 8 are congruent. So those should have been hopefully some of the things that you recognized about your drawing. If you didn't quite recognize that, maybe you want to take your protractor and remeasure your angles, or talk to a friend in class or a neighbor that sits nearby you and see if they can help and tell you what you did wrong. All right, so this is the first problem that we're going to look at, problem 2.11. Lines M and N are parallel, and we are given the measures of one angle in the diagram as shown. We want you to find the values of A, B, C, W, X, Y, and Z. And while we're doing this, we're going to practice justifying them, because on your test and quizzes, you will have to justify them. So the first thing I'm going to do is I'm going to start off by labeling the angles that I'm already familiar with, such as vertical angles and linear pair angles, and so I'll do that first. So the first thing I'm going to do is I'm going to say that angle C is vertical to that 113 degree angle. So this angle C here is 113 degrees by vertical angle theorem. And so then what I want to do is I want to find letter A, and so I know letter A and the 113 degree angle make a straight line, and so they are supplementary because of the linear pair postulate and definition of supplementary. So what I did was I took 180 minus 113, and angle A is 67. And so then again, vertical angle theorem here, A and B are congruent by vertical angle theorem, and so B is also 67. So then finally I have these four angles down, and then that's where I have to use my parallel lines to get to the top four angles. And so since M and N are parallel, I can use any of those angle pairs that I just discovered. So for example, A and X are alternating interiors, so A and X are congruent, so this is 67. Y and 113 are alternating interior, so this is 113. Notice that Y and A add up to 180 because of same side interior angles. So there's lots of different ways you could do this, but now that I'm up here on the top of line M here, I can go ahead and find Z and W. Z and X are vertical, so this one's 67. W and Y are vertical, so this one's 113. And so just by knowing one of the 8 angles, you should be able to find the other 7 angles. And you would be able to justify how you did it, because just because I did it one way doesn't mean that you have to do it the same way. All right, now I'm going to look at problem 2.12. So we have AB is parallel to CD, AD is parallel to BC, and the angles given as shown. And we want to find X and Y. So the first thing that I notice is I notice that this angle right here and this angle right here are going to be 180 degrees. So I'm going to rewrite this angle here as 180 minus, in parentheses, 3x minus 15. And the reason why I'm doing that is because then the next thing I notice is this one that I'm going to label here in green, the 3y plus 15, and this angle right here are corresponding angles, so they are congruent. So this angle is 3y plus 15. And so then by vertical angle theorem, those angles are congruent. So then my equation becomes 3y plus 15 equals 180, distributing my negative 3x plus 15. And so what that does for me is that gets me an equation with 2 unknowns. And so the 15s are going to cancel out, and I'm going to go ahead and add the 3x over. So I have 3x plus 3y equals 180. And so I'm just going to leave that alone for a second. If I want to, I could solve for either y or x, which I think I'm going to go ahead and solve for y. So I'm going to get 3y equals 180 minus 3x. I probably wouldn't have needed to move the 3x. Divide everything by 3, and y equals 60 minus x. And so I'm just going to leave that alone for a minute, see if I can come up with another equation, and then I'll use substitution to solve this problem. So the next thing that I notice is that we probably could use vertical angles to get this angle down here as 3y plus 15, which is the angle A right there. And so then I might be able to do possibly alternating interior angles. That x is going to make this angle here x. And so then my same side interior angles would be 3y plus 15 plus x plus y equals 180 would be my same side interior angles. And so then combining like terms here, I would have 4y plus x equals, and then 180 minus 15 equals 165. And so then what I'm going to do is I'm going to solve using this equation here. Using this equation here, 4y plus x equals 165, and this equation here, y equals 60 minus x. I'm going to solve that system of equations. So let me just see if I can scroll up here for a second here. Oh, this problem's in the way. So let me go to another slide here. Okay, so my two equations were y equals 60 minus x and 4y plus x. 4y plus x equals 165. All right, so I'm going to substitute the 60 minus x in here for y. So I'm going to have 4 times 60 minus x plus x equals 165. Distribute 240 minus 4x plus x equals 165. Go ahead and combine like terms. So 240 minus 3x equals 165. Subtract 240 from 165, and I get negative 75. And then finally divide by negative 3, and x is 25. Now that I know x, I can then go up into this top equation, and y would equal 60 minus 25, so y would be 35. All right, I'm going to skip to problem 2.14. Problem 2.13 is going to be solved in the handwritten notes that I give you. I'll post those on Classroom. So this problem 2.14, what we're going to do is a little bit different. We are going to, first of all, I forgot to tell you an angle. So up here, I forgot to tell you that angle A here is 130 degrees. So this angle here is 130. And so what we're going to do is we're going to add a parallel line, and I'm going to add a parallel line so that it's parallel to line L and M, and it's going to go right through B. So I'm going to sketch this. It's not going to be perfect, but I'm going to add a line right through here, and I'm going to call that line K. And that line K is parallel to line L and M here. What happens when you do that, you add what we call alternating interior angles. So I know that this angle here, x here, is alternating interior up here. So this angle here is x, and so this angle here, down here, is same side interior. So it's kind of little, so I'm going to highlight it right here in the yellow right here. But this angle right here is what I'm talking about. That angle there is same side interior to the 130 degree angle, and so that yellow angle is 50 degrees. And so then x plus 50 is going to equal 90, so x is going to be 40 degrees.